It's 3:47 a.m. at the Arecibo Observatory. The night shift operator is half asleep, nursing cold coffee and watching endless streams of cosmic static dance across her monitors. Then something changes. A pattern emerges from the noise. Not random, not natural, deliberate. For 70 years, we've been listening to the cosmos, waiting for this moment. We've built massive radio telescopes, launched space missions, and scanned millions of stars, all for one purpose: to answer the ultimate question. Are we alone? But what if the answer came tomorrow? What if, right now, as you're watching this video, somewhere in the universe, an alien civilization is pointing their own telescopes at Earth, wondering the same thing? What would first contact really look like? Not the Hollywood version with gleaming spaceships and dramatic speeches. The real thing, the moment everything changes forever. This is the story of humanity's greatest question and our most dangerous dream. Because when we finally make contact, the universe will never look the same again. The search for extraterrestrial intelligence didn't begin with scientists. It began with dreamers. Ancient civilizations looked up at the stars and wondered if other worlds harbored life. But wondering isn't science. Science requires tools, methods, and an almost obsessive patience. In 1960, astronomer Frank Drake pointed a radio telescope at two nearby stars and listened for signals. He called it Project Ozma, named after the princess of the fictional land of Oz. For 200 hours he heard nothing but cosmic silence. But he had started something revolutionary: the search for extraterrestrial intelligence, or SETI. Drake didn't just listen to the stars. He tried to calculate our chances of finding aliens. In 1961, he created what's now known as the Drake equation. It looks deceptively simple, but it contains the answer to one of the universe's biggest mysteries. The equation multiplies several factors: the rate of star formation, the fraction of stars with planets, the number of planets that could support life, the fraction that actually developed life, the fraction that evolved intelligence, the fraction that developed technology we could detect, and finally, how long such civilizations survive. Plug in optimistic numbers and you get thousands of alien civilizations in our galaxy alone. Use pessimistic estimates and Earth might be the only living world for thousands of light years in every direction. The problem is we don't know which numbers to use. We're making educated guesses about the most profound questions in existence. How common is life? How often does it evolve intelligence? How long do technological civilizations survive before destroying themselves? Since Drake's first attempt, we've built bigger telescopes and better computers. We've scanned millions of stars across thousands of hours. We've found thousands of exoplanets, including rocky worlds in the habitable zones of their stars. We've discovered that the ingredients for life, organic molecules, exist throughout the universe. But we still haven't found them. Not a single confirmed signal, not one technosignature, not even a suspicious radio burst that couldn't be explained by natural phenomena. This absence has a name: the Fermi paradox, named after physicist Enrico Fermi, who asked the simple but haunting question: where is everybody? If the universe should be teeming with life, why haven't we found any evidence of it? Maybe we're looking in the wrong places. Maybe advanced civilizations communicate in ways we haven't imagined. Maybe they're out there, but staying deliberately quiet. Or maybe we're about to find out why the universe seems so empty. Because every day our instruments get more sensitive, our search gets broader, and our chances of detection increase. The question isn't whether we'll find aliens, it's what happens when we do. Hollywood has been preparing us for first contact for decades. In Contact, alien mathematics arrives as radio signals from Vega carrying blueprints for a mysterious machine. In Arrival, ship-sized objects appear over major cities, forcing linguists to decode an alien language that thinks in circles rather than lines. In Independence Day, massive ships block out the sun before unleashing devastating attacks. These stories shape our expectations. They make first contact feel familiar, even inevitable. But they also reveal something interesting about human psychology. We can't imagine aliens without imagining ourselves. The aliens in our stories often reflect our own hopes and fears. Peaceful aliens come bearing gifts of knowledge and technology. Hostile aliens want to conquer, colonize, or exterminate us. Noble aliens test our worthiness to join a galactic community. But real aliens won't be characters in a human story. They'll be the products of completely different evolutionary pressures, different environments, different histories. Consider the most realistic first contact movie ever made, Contact. The signal comes as radio waves, just like city scientists expect. The message contains mathematical proofs, a universal language that any technological civilization would understand. The aliens don't reveal themselves immediately. Instead, they send instructions for building a machine whose purpose remains mysterious. This feels scientifically plausible because it's based on real SETI protocols. When we receive an alien signal, the first priority won't be communication. It will be verification. Is this really from aliens, or is it interference from a microwave oven, a satellite, or a classified military experiment? In 1977, astronomer Jerry Emmon detected a strong radio signal from the direction of Sagittarius. The signal was exactly the kind SETI scientists hoped to find. Narrowband, not produced by any known natural phenomenon, and lasting exactly 72 seconds before disappearing forever. Emmon wrote "Wow" on the printout, giving the signal its famous name. 46 years later, we still don't know what caused the wow signal. Despite dozens of attempts, it has never repeated. It might have been aliens, it might have been a comet. It might have been interference from Earth-based technology. The uncertainty drives home a crucial point. Real first contact won't come with obvious explanations or clear intentions. The aliens in Arrival communicate through circular symbols that represent entire concepts rather than individual words. This linguistic challenge is probably the most realistic part of any first contact movie. How do you talk to a mind that evolved on a different world? How do you establish meaning without shared references? Even human languages can be nearly impossible to translate. Ancient Linear A script from Crete remains undeciphered after a century of study. We're trying to decode the communication of our own species on our own planet from our own recent history. Now imagine trying to decode the thoughts of beings that evolved under an alien sun. But Hollywood gets one thing fundamentally wrong: the timeline. Movies compress first contact into days or weeks. Real first contact will likely unfold over years or decades. The aliens might be hundreds or thousands of light years away. A simple hello could take centuries to cross the void between stars. Their response could take centuries more. This slow-motion conversation changes everything. There won't be dramatic face-to-face meetings or urgent negotiations. Instead, humanity will have time to study the signal, decode the message, and decide how to respond. We'll have time to prepare, to argue, to change our minds 1,000 times. That might be the scariest part of all, because if we have time to think, we also have time to make mistakes. The most likely scenario for first contact isn't dramatic, it's accidental. Right now, radio waves from Earth are spreading into space at the speed of light. Our television broadcasts, radar systems, and cellular networks create a bubble of electromagnetic signals around our planet. This bubble has been expanding since the 1930s, when we first began serious radio transmission. Any civilization within about 90 light years could, in theory, detect our presence, but we're accidental broadcasters. We never intended those signals as messages to aliens. Similarly, our first detection of alien civilization will probably be accidental too. We'll eavesdrop on their equivalent of television shows, military radar, or interplanetary communications. SETI scientists call these technosignatures the technological fingerprints that advanced civilizations leave on the cosmos. Unlike biosignatures, which indicate the presence of life, technosignatures specifically indicate intelligence. They're harder to fake with natural phenomena, but they're also much rarer. The most obvious technosignature would be narrowband radio transmissions. Natural cosmic phenomena produce radio waves across wide frequency ranges, like white noise. Artificial transmissions focus on specific frequencies like tuning into a radio station. A narrowband signal from space would be strong evidence of technology. But advanced civilizations might communicate in ways we haven't mastered yet. They might use neutrino beams, gravitational waves, or exotic particles we haven't discovered. They might encode their messages in the quantum properties of light or manipulate the magnetic fields of stars. We're listening for radio signals because that's the technology we understand, not necessarily the technology they use. There's another possibility: megastructures. A sufficiently advanced civilization might build massive engineering projects that alter the appearance of their star system. In 1960, physicist Freeman Dyson proposed that advanced aliens might surround their star with a sphere of solar collectors, capturing every photon of energy. These Dyson spheres would be invisible to optical telescopes, but blazingly bright in infrared. The star would disappear, replaced by a warm artificial structure radiating waste heat into space. We've searched for these infrared signatures and found some intriguing candidates, but nothing conclusive. A more realistic megastructure might be a swarm of solar collectors in orbit around a star. This wouldn't block all the star's light, but it would create periodic dimming as the structures pass in front of the star. In 2015, the Kepler Space Telescope detected exactly this kind of irregular dimming around a star called KIC 8,462,852, nicknamed Tabby's star. The dimming patterns were unlike anything caused by planets or natural phenomena. The star would dim by up to 22%, stay dim for days or weeks, then return to normal brightness. Some astronomers speculated about alien megastructures. Others proposed natural explanations: dust clouds, comet swarms, or stellar instabilities. 4 years of follow-up observations favor the natural explanations, but Tabby's star proved an important point. When we finally detect aliens, it might not be through their messages. It might be through their engineering projects, their industrial pollution, or their accidental influence on their environment. The search for technosignatures has expanded beyond radio waves. Astronomers now look for laser pulses, industrial pollutants in exoplanet atmospheres, and artificial lights on the night sides of distant worlds. We search for the heat signatures of massive computers and the chemical signatures of rocket exhaust. But perhaps the most likely first contact scenario involves neither radio signals nor megastructures. Perhaps aliens will find us first. If a civilization is actively searching for life, Earth would be an obvious target. Our planet shows clear biosignatures, oxygen and water vapor in our atmosphere, seasonal changes in vegetation, and increasingly obvious technosignatures from our own industrial activity. An advanced alien civilization might send automated probes to investigate promising solar systems. These probes could already be here, quietly studying our civilization from the outer reaches of our solar system. They might have been waiting in the asteroid belt for centuries, programmed to activate when they detect signs of intelligence on Earth. This scenario has a name, the Zoo hypothesis. It suggests that aliens know about us but are observing from a distance, like scientists studying animals in a nature preserve. They're waiting for us to reach a certain level of technological or social development before making contact. If this is true, then first contact won't happen when we're ready. It will happen when they decide we're ready. The implications are staggering. Every scenario for first contact changes not just science, but politics, philosophy, and the fundamental story we tell about humanity's place in the universe. But not every scenario is hopeful. Stephen Hawking warned us to be quiet. The renowned physicist believed that advertising our presence to the cosmos was playing with fire. His reasoning was simple and terrifying. Any civilization capable of interstellar travel would be so technologically advanced that we would be powerless to resist them. Think about what happened when technologically advanced civilizations encountered less advanced ones here on Earth. The arrival of Europeans in the Americas led to the collapse of entire cultures, not through malice alone, but through disease, resource competition, and simple technological inequality. Now imagine that same dynamic, but with aliens who might be millions of years more advanced than us. This fear has inspired one of the most chilling theories in astrobiology, the dark forest hypothesis. Proposed by Chinese science fiction author Liu Cixin, it suggests that the universe is like a dark forest where every civilization is a hunter, moving quietly through the trees. The logic is brutal but compelling. In a universe full of potentially hostile civilizations, the safest strategy is to remain hidden. Any civilization that reveals its location risks destruction by others who view it as a potential threat. Therefore, wise civilizations stay silent, listening but never broadcasting. This would explain the Fermi paradox. The universe isn't empty. It's full of civilizations that have learned to keep quiet. They've all discovered the same terrible truth. Making noise in the cosmic dark forest is a death sentence. The dark forest hypothesis assumes that resources are limited and that civilizations naturally compete for them. It assumes that alien psychology includes traits like fear, aggression, and mistrust. But these assumptions might be wrong. Cooperation could be more advantageous than competition for spacefaring civilizations. The universe might be vast enough for everyone. Still, the risk remains real. We've been broadcasting into space for decades, and there's no way to take those signals back. Our radio emissions have already revealed our location to any advanced civilizations within 90 light years. If hostile aliens exist in that sphere, they already know about us. But the risks of first contact go beyond alien invasion. The mere knowledge that we're not alone could destabilize human civilization in ways we can't predict. Consider the psychological impact. Humanity has spent its entire history believing that Earth is the center of creation, that intelligence is rare and precious, that we are special. The discovery of alien intelligence would shatter these assumptions overnight. Some people might find this liberating. Others might find it devastating. Religious institutions would face unprecedented challenges. How would Christianity adapt to the knowledge that God created intelligent life on millions of worlds? How would Islam reconcile the Quran's focus on humanity with the existence of alien civilizations? Some faiths might evolve and expand their worldview. Others might retreat into fundamentalism or denial. The economic implications could be equally disruptive. If aliens possess advanced technology, they might share knowledge that renders entire industries obsolete. Imagine aliens providing unlimited clean energy, advanced medicine, or efficient space travel. These gifts could solve humanity's greatest problems, but they could also crash global markets and eliminate millions of jobs overnight. Political systems might struggle to cope with first contact. Nations spend enormous resources on military defense, space programs, and scientific research. The arrival of vastly superior alien technology could make these investments seem pointless. Some governments might embrace cooperation with aliens. Others might view them as an existential threat to national sovereignty. There's also the risk of misinformation and panic. The initial alien signal might be ambiguous, open to multiple interpretations. While scientists work to decode the message, conspiracy theories and wild speculation could spread faster than facts. Social media could amplify fear and confusion, leading to market crashes, social unrest, or even violence against perceived alien collaborators. History shows us how quickly misinformation can spread. In 1938, Orson Welles' radio adaptation of The War of the Worlds convinced some listeners that Martians were actually invading Earth. This was fiction presented as news, yet it caused genuine panic. Now imagine the chaos if people believed that real aliens had arrived and had hostile intentions. The aliens themselves might not even intend harm. They might be genuinely peaceful, offering friendship and knowledge. But good intentions don't guarantee good outcomes. European diseases devastated Native American populations even when there was no deliberate attempt at biological warfare. Alien microbes, technology, or ideas could have similarly unintended consequences for humanity. Perhaps the greatest risk is that we might not be ready. First contact will be the most important moment in human history, but it won't come with an instruction manual. We'll have to make decisions that affect our species' entire future, and we'll have to make them quickly, under enormous pressure, with incomplete information. We might choose poorly. We might respond with fear instead of curiosity, aggression instead of diplomacy, or chaos instead of careful planning. We might squander the greatest opportunity in human history because we're too frightened, too divided, or too unprepared to seize it. But what if we choose wisely? What if first contact becomes humanity's greatest triumph instead of its greatest tragedy? Imagine receiving a message that begins with the prime numbers 2, 3, 5, 7, 11, 13. Then comes the Fibonacci sequence 1, 1, 2, 3, 5, 8, 13. Finally, mathematical constants, pi, the square root of 2, Euler's number. This is the universal language, comprehensible to any technological civilization. But after establishing mathematical communication, what comes next? The possibilities are breathtaking. An alien civilization millions of years old would possess knowledge that could transform human civilization overnight. They might have solved the greatest challenges facing our species: climate change, disease, poverty, and war. They could share clean energy technology that makes fossil fuels obsolete, medical advances that extend human lifespan to centuries, or agricultural techniques that could feed 10 billion people without environmental destruction. The scientific revolution would be unprecedented. Einstein's theories transformed our understanding of space and time, leading to GPS, satellites, nuclear power, and particle accelerators. Darwin's insights revolutionized biology, medicine, and our understanding of life itself. Newton's laws enabled the Industrial Revolution and space exploration. Now imagine receiving the complete scientific knowledge of a civilization that has had millions of years to explore the universe. They might understand physics principles we haven't discovered yet. They could reveal new dimensions, exotic forms of matter, or technologies that seem like magic to us today. Faster than light travel might actually be possible through methods we haven't conceived. They might manipulate space-time itself, creating shortcuts through higher dimensions, or discover particles that travel backward through time. They could teach us to build starships that reach other worlds in years, instead of millennia. The implications extend beyond technology to philosophy and consciousness itself. How does intelligence evolve on different worlds? Do aliens experience emotions, creativity, or love? Do they create art, music, or literature? Their answers could reveal new dimensions of what it means to be a thinking, feeling being. Contact with aliens might also solve the deepest mysteries of existence. How did life begin? Is consciousness an inevitable product of complex information processing, or something more mysterious? Are there other universes beyond our own? Do physical laws remain constant across space and time? But perhaps the greatest gift of first contact would be perspective. For the first time in human history, we would see ourselves through alien eyes. We might discover that traits we consider uniquely human, like creativity or compassion, are actually universal among intelligent species. Or we might find that humans possess rare qualities that make us valuable contributors to a galactic community. This shift in perspective could transform how we see each other. The divisions that separate human cultures, races, and nations might seem trivial compared to the gulf between Earth life and alien life. We might finally recognize that we're all members of the same planetary family, sharing a common origin and a common destiny among the stars. The psychological benefits could be enormous. Many people feel isolated and insignificant in the vastness of space. The knowledge that intelligence exists throughout the universe could provide comfort and connection. We wouldn't be alone, struggling with existence in an indifferent cosmos. We would be part of a vast community of thinking beings, each contributing their unique perspective to the universe's understanding of itself. First contact might even accelerate human cultural evolution. Exposure to alien art, philosophy, and ways of thinking could inspire new forms of human creativity. We might discover that our assumptions about reality, morality, or beauty are just one of many possible perspectives. This could lead to a renaissance of human culture, comparable to the explosion of art and science during the European Renaissance or the Islamic Golden Age. The practical benefits could be equally transformative. Aliens might have developed sustainable ways of organizing society that eliminate poverty, inequality, and conflict. They might have created economic systems based on abundance rather than scarcity, or political systems that actually serve the needs of all citizens rather than powerful elites. They could teach us to terraform other worlds, establishing human colonies on Mars, Venus, or the moons of Jupiter. They might provide the technology needed for generation ships that could carry human civilization to other star systems. Within a few centuries, humanity could spread throughout the galaxy, ensuring our survival, even if Earth faces catastrophe. The medical advances alone could be revolutionary. Aliens that have existed for millions of years have probably solved aging, disease, and death itself. They might share techniques for repairing damaged tissues, enhancing human intelligence, or uploading consciousness to computer systems. Death might become optional, aging might become reversible, and human potential might become unlimited. But perhaps the most profound impact would be spiritual. Many humans search for meaning and purpose in life. The discovery that we're part of a vast cosmic community could provide the sense of significance that many people lack. We might realize that Earth life represents a unique and precious experiment in the universe's evolution toward greater complexity and consciousness. Some scientists speculate that sufficiently advanced civilizations might be building something magnificent, a network of intelligence that spans the galaxy, sharing knowledge and perspectives across thousands of worlds. Earth might be invited to join this network, adding our unique human perspective to a collective understanding that encompasses millions of different ways of experiencing reality. The universe might not be cold and empty after all. It might be warm with intelligence, creativity, and wonder. And we might be about to discover that we've always been part of something much larger and more beautiful than we ever imagined. But first we have to find them, or wait for them to find us. Right now, as you watch this video, radio telescopes around the world are listening to the cosmos. The Very Large Array in New Mexico scans the sky with 27 massive dishes. The Arecibo Observatory in Puerto Rico, before its collapse in 2020, spent decades searching for alien signals. The Green Bank Telescope in West Virginia, located in the National Radio Quiet Zone, listens to frequencies protected from human interference. These searches have become increasingly sophisticated. Modern SETI uses artificial intelligence to sift through vast amounts of data, looking for patterns that human analysts might miss. Machine learning algorithms can identify anomalous signals in real time, flagging potential alien transmissions for immediate follow-up. The most ambitious search is Breakthrough Listen, a 10-year, $100 million project launched in 2015. It's surveying 1 million nearby stars, the entire galactic plane, and 100 nearby galaxies. The project has access to some of the world's most powerful radio telescopes and can detect signals thousands of times fainter than previous searches. Breakthrough Listen has already made intriguing discoveries. In 2019, the project detected a narrowband radio signal from Proxima Centauri, the closest star to our solar system. The signal, dubbed BLC-1, appeared to shift in frequency in a way that suggested it originated from a planet orbiting the star. For months, it seemed like the best candidate for an alien signal ever detected. But further analysis revealed a disappointing truth. BLC-1 was caused by human technology, probably a malfunctioning piece of electronic equipment on Earth. The signal's apparent planetary origin was a coincidence. It was another false alarm in the long history of SETI, a reminder that extraordinary claims require extraordinary evidence. The search has expanded beyond radio waves. Breakthrough Listen also searches for laser pulses from nearby stars. Aliens might communicate using brief, powerful flashes of light that could be detected across interstellar distances. Optical SETI searches for these signals using automated telescopes that can monitor thousands of stars simultaneously. We're also searching for technosignatures in the atmospheres of distant planets. Industrial civilizations might pollute their air with chemicals that don't occur naturally. Nitrogen dioxide, chlorofluorocarbons, or other industrial gases could be detectable in the atmospheres of nearby exoplanets. The James Webb Space Telescope, launched in 2021, has the sensitivity to detect these artificial signatures. The search for alien megastructures continues too. Astronomers monitor millions of stars for the telltale dimming patterns that might indicate artificial structures. They look for excess infrared radiation that could indicate Dyson spheres or other massive engineering projects. They search for the heat signatures of alien computers or the optical flashes of interstellar spacecraft. But perhaps the most exciting development is our growing catalog of potentially habitable worlds. The Kepler Space Telescope discovered thousands of exoplanets before ending its mission in 2018. Its successor, the Transiting Exoplanet Survey satellite, TESS, continues to find new worlds around nearby stars. Many of these planets lie in the habitable zone around their stars where liquid water could exist on their surfaces. Some are rocky worlds similar to Earth. Others might be super-Earths, larger than our planet, but potentially more suitable for life. A few orbit in the habitable zones of red dwarf stars, which could remain stable for trillions of years. The closest potentially habitable planet is Proxima Centauri b, just 4.2 light-years from Earth. This world orbits a red dwarf star and might have the right conditions for liquid water. Other intriguing candidates include TRAPPIST-1e, Wolf 1061c, and Kepler-4 42b. Each represents a possible home for alien life. Detecting life on these worlds requires different techniques than SETI. Instead of searching for radio signals or megastructures, astrobiologists look for biosignatures, oxygen in the atmosphere, seasonal changes in vegetation, or the chemical signatures of biological processes. These signs of life wouldn't necessarily indicate intelligence, but they would prove that we're not alone. The James Webb Space Telescope is revolutionizing our ability to study exoplanet atmospheres. It can detect water vapor, carbon dioxide, methane, and other gases in the air of distant worlds. Within the next decade, it might find clear evidence of life beyond our solar system. But even our own solar system might harbor life. Jupiter's moon, Europa, probably contains more liquid water than all of Earth's oceans, hidden beneath a shell of ice. Saturn's moon, Enceladus, shoots geysers of water into space from an underground ocean. Mars shows evidence of ancient rivers and lakes and might still have liquid water underground. Robotic missions are searching for life in these environments. The Perseverance rover is collecting samples from Mars that might contain fossilized microbes. Future missions will drill through the ice shells of Europa and Enceladus, searching for life in their hidden oceans. The search for life and intelligence has never been more promising. We have better instruments, more sophisticated analysis techniques, and a growing list of targets to investigate. We're searching the radio spectrum, the infrared sky, and the atmospheres of distant worlds. We're exploring our own solar system and cataloging thousands of exoplanets. Statistical analysis suggests that we're on the verge of a breakthrough. If aliens exist and communicate using technologies we can detect, we should find evidence within the next few decades. The calculation is simple. We're improving our instruments faster than we're exhausting our list of targets. But statistics can't predict the moment of discovery. It could happen tomorrow, or it could take another century. The signal could come from Alpha Centauri, just 4 light-years away, or from a galaxy millions of light-years distant. Whenever and wherever it happens, first contact will mark the beginning of a new era for humanity. The age of isolation will end, and the age of cosmic citizenship will begin. The only question is, are we ready? It's 3:47 a.m. at a radio telescope somewhere on Earth. The night shift operator is monitoring the automated systems, watching data streams from 100 different targets. Most nights are quiet, most signals are noise, but tonight is different. The computer flags an anomaly, a narrow-band signal from the direction of a nearby star. The frequency is precisely 1420.4 megahertz, the natural emission line of hydrogen, the most abundant element in the universe. But this signal is too structured, too organized to be natural. The operator's hands shake as she verifies the detection. She runs diagnostic tests, checks for equipment malfunctions, searches for terrestrial interference. Everything checks out. The signal is real, artificial, and extraterrestrial. She picks up the phone to call her supervisor. In that moment, everything changes forever. This scenario isn't science fiction. It's a realistic projection of how first contact might unfold. The instruments exist. The search is ongoing. The discovery could happen at any time. When it does happen, the first few hours will be crucial. Scientists will need to verify the signal, decode the message, and decide how to respond. Governments will need to coordinate their actions, manage public reaction, and prepare for the most significant moment in human history. But the real work will just be beginning. First contact won't be a single event, but a process that could take decades or centuries to unfold. We'll need to learn how to communicate with minds that evolved under alien suns. We'll need to navigate the risks and opportunities of joining a cosmic community. We'll need to decide who we want to be when we're no longer alone. The universe is vast beyond imagination. Our galaxy contains hundreds of billions of stars. The observable universe contains hundreds of billions of galaxies. The total number of potentially habitable worlds is literally astronomical. Yet in all this vastness, we've found only one world that definitely harbors life: Earth. We've detected only one example of intelligence: ourselves. We may be unique, or we may be one of countless civilizations scattered across space and time. The answer to this mystery will reshape our understanding of life, intelligence, and our place in the cosmos. It will challenge our religions, revolutionize our science, and transform our philosophy. It will force us to see ourselves not as the center of creation, but as participants in a much larger story. That story might be just beginning, or it might have been unfolding for millions of years, waiting for us to develop the technology to join the conversation. The search continues every day, every night, around the world. Radio telescopes scan the sky. Space missions explore nearby worlds. Scientists analyze the atmospheres of distant planets, looking for signs of life or intelligence. Each new discovery brings us closer to the answer. Each technological advance increases our chances of detection. Each passing day makes first contact more likely. The call might come tomorrow. It might come from a civilization that has been trying to contact us for centuries, broadcasting into the void and waiting patiently for us to develop ears capable of hearing their message. It might come from explorers who have traveled thousands of light years to find us. It might come from neighbors who have been watching us from the outer reaches of our own solar system. Or it might not come at all. We might be alone, the only intelligence in a vast and empty universe. The silence might be real, not a consequence of our limited technology or our brief history of searching, but a fundamental truth about the rarity of life and consciousness. But the search itself has value, regardless of what we find. It represents humanity at its best, curious, determined, and willing to ask the biggest questions imaginable. It shows that we're not content to remain isolated on our small world, accepting ignorance about the universe beyond our atmosphere. The search for extraterrestrial intelligence is ultimately a search for ourselves. We're trying to understand what makes intelligence possible, how it emerges from the complexity of matter and energy, and whether our particular form of consciousness is universal or unique. The answer will tell us whether we're alone in our struggles with existence, mortality, and meaning, or whether we're part of a vast community of beings grappling with the same fundamental questions about reality and purpose. Either answer will be profound. Either answer will change us forever. So we keep listening, we keep searching, we keep asking the biggest question in science. Are we alone? And someday, maybe soon, the universe will answer back. If that call came tomorrow, if radio telescopes around the world suddenly detected an unmistakable signal from another world, if we found ourselves face to face with the knowledge that we are not alone in the universe, how would we answer? What would we say to minds that have traveled across the void to find us, or waited patiently for us to develop the technology to hear their ancient messages? What would we want them to know about humanity, about Earth, about our dreams and fears and hopes for the future? The answer to that question might be the most important thing we ever decide as a species, because in that moment, we won't just be representing ourselves. We'll be representing all of Earth's life, all of our planet's history, all of our species' potential. We'll be introducing ourselves to the universe, and the universe will finally know our name.